Welcome back to ChemTube channel. Today we are going to discuss the Terengganu trial papers to essay part. Let's start. Question 7. Diagram 7.1 shows the label on the ice cream container. The ingredients given are cream, non-fat milk, sugar, sunset yellow, vanilla, flavor, soy lecithin. So from the diagram, set the name of two food additives found on the label. State the type and the function of each food additives. So justify using the food additives by giving one advantage and one disadvantage. So there are 8 marks in total. So how do we present our answer? You can write your answer in a table form like this. So for example, sunset yellow actually is a food coloring, yellow color. So actually the function is to improve the appearance of the food. Second one is the vanilla flavor, is a flavoring to improve the taste of the food. Sugar is a preservative to keep the food last longer. And finally is a soy lecithin, and it's a stabilizer to allow the oil mix with the water. So actually you can pick any two of these food additives, okay, and then list out the food type and then the function. So you can pick any two of the food additives here. So total is 6 marks. So after that, you can list out the advantage of the food additives you have listed. So you can choose make the food last longer if you choose the preservative, more attractive for flavoring, for the coloring, and then better taste for the flavoring. This advantage you can put, it will cause disease like cancer, asthma, allergy, and hyperactive. B. Table shows the traditional medicine and their uses. Okay, so you have, if you have, you can see here aloe vera. Okay, its juice is used to treat the skin wounds and burns. Then you are given two types of traditional medicine here, X and Y. X, the function is to remove the winds from the body, and Y used to treat the flu. So as a chemistry student, you should know the X actually here state the name of the traditional medicine for X and Y. So X, you should know it is actually is a ginger, then Y is a garlic. So 2 marks each answer here. Next, if the burns is not treated properly, it may get infection. So infection here, it will be caused by the bacteria or the virus. It becomes worse. If the person is brought to the clinic, state the type of the medicine prescribed by the doctor and state the function of the medicine. So here you should know it is the type of medicine should be antibiotics. And then the function is to destroy the microorganism and prevent the growth of the microorganisms. Okay, C. Diagram shows the structure formula for the cleaning agent A and B. So A, if we look into the diagrams here, the functional group is a sulfonate and ion, so we know this is a detergent. Okay, and then for B is a carbonate, so it is the salt. So we know that the A is detergent, B is the salt. Okay, next, you are given 2 sets of experiments to compare the effectiveness for the cleaning action of the cleaning agent in the hot water. In the hot water. So, okay, you are given set 1 and set 2. Okay, cleaning agent A just now is detergent and B is the salt. Huh? Okay. So based on the structural formula, okay, identify the cleaning agent A and B, then state the observation for set 1 and 2, then compare and contrast the effectiveness of the cleaning action of 2 cleaning agents in hot water, and then explain your answer. So total is 8 marks. Huh? Before we go to the answer, we look into the videos here. So set 1. Okay, so the cloth is put into the hot water with the cleaning agent A. So you can see the observation. Then set 2. Okay, it's still not clean. Not clean. Okay, so based on the observation here, okay, we can try to explain the answer. So here I give you the cleaning agent A and B. Okay, so this is the detergent, detergent. And B is the salt. Okay, now we try to suggest some answers. Okay, so cleaning agent A is a detergent, cleaning agent B is a salt. So 2 marks. So first you can mention the word hot water contains the calcium ions and the magnesium ions. So whenever you face or you see the hot water, remember to put in these two point. Okay, next you can use a table to present your answer. So cleaning agent A or detergent, okay, oily stain remove. B is oily stain remains. Okay, so detergent is effective in hot water. B is not effective in the hot water. Okay, so next explanation we can write is anion cleaning agent A or detergent react with calcium ions or magnesium ions in hot water to form the soluble salt. Okay, or no scum is formed. Okay, for cleaning agent B, which is the salt, it reacts with calcium ions or magnesium ions in the hot water to form the insoluble salt or to form the scum. Okay, question 8. Diagram shows the apparatus set up to determine the endpoint of titration through the electrical conductivity method. 20 cubic centimeter of 1 mole per cubic decimeter sodium hydroxide solution is neutralized by X mole per cubic decimeter of the sulfuric acid. So sulfuric acid is put inside the burette, then in the beaker is sodium hydroxide. Okay, so let's look into this video to see how we conduct this experiment.
Put 50 cubic centimeters of electrolytic cell. Place a beaker of sodium hydroxide on a magnetic stirrer. Dip the carbon rods into sodium hydroxide solution. Close the circuit. Switch on the magnetic stirrer and adjust the acid flow from the burette into the beaker drop by drop. Record the ammeter readings and volume of acid added. From the data collected, we can plot a graph of electrical conductivity versus volume of acid added. At first, the ammeter readings is at its highest, then gradually drop until there is no reading. As more acid added, the ammeter readings increase. What information can you get from this graph? Click on the boxes. At the beginning, there are many hydroxide ions present. When acid is added, hydrogen ions from the acid combine with the hydroxide ions to form water molecules. Thus, less and less hydroxide ions discharged at the electrode. Therefore, the ammeter readings decrease with the increasing amount of acid added. At this point, the ammeter reading is 0. All hydroxide ions present are neutralized by the hydrogen ions from the acid to form water molecule. As more and more acid is added, the ammeter reading increases gradually. This is because there are excess of hydrogen ions present in the solution. Now, from the graph, can you determine the end point? Click on the point along the line.
Okay, so we look into the question. A graph of the electrical conductivity ammeter reading against the volume of the sulfuric acid is then plotted. The end point of the titration during the neutralization can be determined. Okay, when the electrical conductivity is the lowest. So actually, if you see here, this is the end point. Okay, this point is the end point. So, okay. Now, write the chemical equations for the reaction that occur in the diagram 8.1 determines the value of X. Value of X means the concentration of the sulfuric acid. So first one, you have to mention about the write the chemical equation. Okay, so the chemical equation here is sodium hydroxide react with the sulfuric acid to produce the sodium sulfate and the water. So this is the neutralization. So to determine the value of the X is a concentration of the acid. So we use the formula. Okay, MAVA over MBVB equals to A over B. So here we look into the equation here. The sodium hydroxide is the MB is 2 mole. Okay, then sulfuric acid is 1 mole. So we can replace in all the information here. MA is actually the X concentration of the acid. VA is the volume of the acid used. So here we know that the volume of acid used is 10 cubic centimeter to neutralize the alkaline. So for the MB is the concentration of the sodium hydroxide is 1. So VB is the volume of the alkaline, sodium hydroxide. So here A and B. A for acid is 1. B for the mole for the alkali is a 2. So we can replace in all the information. Then find the MA. MA is the X now. So it's 20 divided by 20. So it's 1 mole per cubic decimeter. So it's 20. This is the answer. Okay. So this one is 2 marks. Then here the calculation here is 4 marks. So okay, you still need to explain. So they still have some free moving ions in the beaker, and then the ions then carry some electrical charges. Okay, during the end points here. Okay, B. Diagram shows 2 sets of experiments for the reaction between the strong acid and weak acid with the excess calcium carbonate. Is the marble chip. Then the concentration and the volume of the acid used are the same. So the gas that produced from the reaction is channeled into the lime water. Okay, here I provide one videos about the reaction between the marble chips, the calcium carbonate with the acid. So put in the acid, you can see a lot of bubbles are produced, and the bubbles is channeled into the gas is channeled into the lime water, then the lime water it turns chalky. Okay, now we look into here set 1. The time taken for the lime water turns chalky is longer. Then for set 2, okay, the time taken is shorter. Okay, both acids used can react with the marble chips, calcium carbonate, no? But this one takes longer time. Set 2 takes shorter time. In other words, we know that this acid Q is a stronger acid compared to acid P. Okay, now we look into the question. So based on the information, suggest the name of the acid P and acid Q. So here, okay, so acid P, we know that is an ionic weak acid. Weak acid is a chemical substance that ionize partially, okay, to form the hydrogen ions in the water. So degree of ionization is less than 100 now. So here we can suggest acid P is ethanoic acid or any name of the weak acid. Okay. Then for Q is a strong acid. So strong acid is a chemical substance that ionizes completely. So degree of ionization is 100%. So you can suggest any one of these strong acid, hydrochloric acid, nitric acid or sulfuric acid. So you have to give the name. You cannot use any formula. So 2 marks. So the reaction between the acid P and with the calcium carbonate and the acid Q with the calcium carbonate give the different observation. Explain why. So here you have to use the strong acid and the weak acid for your explanation. Okay, just now I mentioned to you already. So point number 1 here, acid P or ethanoic acid is a weak acid that ionizes partially in water to produce low concentration of hydrogen ions, or low concentration. Then it releases low volume of carbon dioxide gas, so lower rate of reaction, that it takes longer time to turn the lime water to chalky. Then for acid Q is a strong acid. You can mention the name. Hydrochloric acid is a strong acid, ionized completely in water, produce high concentration of hydrogen ions, and it releases more volume of the carbon dioxide gas, and it has a higher rate of reaction. So there are 8 points here you can write. So total is 10 marks for this question. Okay, plus the 2 marks in the first question just now. Okay, C. Table shows the pH value of 2 solutions which have the same concentration. So here, sodium hydroxide. Okay, I give you provide you some picture here. Sodium hydroxide, and then this is ammonia. So same concentration but different pH value. So explain why the pH value for 2 solutions are different. So 4 marks. So suggested answer. Point number 1, sodium hydroxide is a strong alkali and ammonia is a weak alkali. So this is point number 1. So sodium hydroxide ionizes completely in water, produce high concentration of hydroxide ions. So for alkaline, so the ions that are responsible is hydroxide ions. The ammonia ionizes partially again. Okay, this one for strong it will be completely. Then in water produce low concentration of hydroxide ions. So the higher the concentration of hydroxide ions, the higher the pH value. So 4 marks, 4 points. Okay, question 9. Table shows the result of 2 sets of experiments to investigate the coagulation of latex. Coagulation means to turn the latex into the solid. Okay, set 1, latex with the solution P, then it coagulates very fast. Okay, set 2, latex with solution Q, latex does not coagulate. So just suggest one possible substance for P and Q, so 2 marks. Let's have a look on this video.
Let us do an experiment to check what happens to latex during coagulation. Take a beaker containing latex. Now add acid to beaker. After some time, we can see the latex in the beaker coagulates. Why does this happen so? When weak acid is added to latex, it coagulates. The hydrogen ions released will neutralize the negative charge of the protein membrane. The free-moving rubber particles no longer repel each other. Instead, they collide with each other. The collision of the rubber particles results in breakage of the thin protein membrane. The rubber molecules tend to clump together. Therefore, latex coagulates. Why do latex in box B do not coagulate? Addition of ammonia or alkalis helps to maintain their negative charges. This will keep the rubber particles to repel each other, and the latex remains as a suspension.
Okay, so based on the video just now, I think you should be able to guess the solution P. It makes the latex to coagulate, so it should be weak acid now, weak acid. So actually you can put any acid, okay, but normally we use ethanoic acid now, ethanoic acid. So Q, just now we also can see from the video, is ammonia, or any alkaline actually. Okay, so explain the observation in set 1 and set 2. Actually, just now from the videos, okay, we already see the explanation. Okay, so you can refer back to the video just now if you want. So actually, if we look into details on the protein membranes of the rubber, you can see it is surrounded by the negative charges. So if the negative charges remains, so the rubber molecules, it will repel each other. So unless the negative charges is neutralized by the hydrogen ions from the acid, then it can neutralize, then it can collide with each other, then it can coagulate. So 6 marks here, so suggest the answer. For set 1, so ethanoic acid contains hydrogen ions. Then hydrogen ions, it can neutralize the negative charges of the protein membrane. So the negative charges are all here. Okay, so it can neutralize the negative charges here. So the rubber particles now, they can collide with each other. They can collide with another protein membrane. Then the protein membranes, it can break, and then the rubber molecules can combine together. So it can coagulate. Okay, so for set 2, the ammonia solution contains the hydroxide ions. So the hydroxide ions, it will neutralize the hydrogen ions produced by the bacteria from the air. So meaning that the negative charges on the protein membranes here remains. If it is there remains, means they will repel with each other. So no collisions can occur. So it remains in the liquid form. It does not coagulate. Okay, diagram shows how the compound Y is formed from the alkene. Okay, so alkene react with water, then produce the compound Y. So state the homologous series and 2 chemical properties of the compound Y. So 3 marks. Actually, alkene react with the water is you produce alcohol. So this one, the homologous series for the compound Y is alcohol. Then the 2 chemical properties of the alcohol it can burn in oxygen to produce carbon dioxide and water. And then another one, it can oxidize by oxidizing agent to produce a carboxylic acid. So 3 marks. By using a compound Y with more than 1 carbon atom per molecule, describe an experiment to convert the compound Y to alkene X. So actually, if we look into here, means convert back. Just now the process from alkene with water, this is the hydration process. If reverse back, actually is the dehydration. So dehydration here, okay, so your answer should include procedural, label diagrams, and then the chemical test to confirm the products. Okay, now I show you a video on the dehydration process.
Click the play button to see what happens when ethanol vapor is heated strongly over porcelain chips.
So you can test with bromine water or acidified potassium magnate 7. So it turns to colorless. For bromine, it will be brown bromine water. It turns to colorless. Okay. So the procedure just now. Okay. Number 1, you can place a glass wool into the boiling tube. Then soak the glass wool with 2 cubic centimeter of the ethanol. Then place pieces of porcelain chips in the boiling tube, and then heat the porcelain chips strongly, and then heat the glass wool gently. Okay. Then the diagrams for the dehydration. So you can see all the diagrams must be functional, and then you have to label it. Okay. So just a reminder here, your stopper cannot be fully immersed into the combustion tube here. Okay, it must be a little bit coming out. Okay, then the level of the delivery tube cannot over the level of the water. Then the gas is produced, the gas X. Okay. Next, the chemical test. Okay, action: add few drops of bromine water into the test tubes, contain the gas X, then brown color change to colorless. Okay, question 10. Diagram shows the thermochemical equations for the formation of silver chloride. Okay, so silver ions react with chloride ions, produce a silver chloride. The delta H, the heat of this precipitation is negative 65.5 kilojoule per mole. So this is a thermochemical equation. So now I show you one video how to conduct this experiment.
Silver chloride is produced when silver nitrate is added to sodium chloride.
So you can see the white precipitate is formed, which is the silver chloride. Then final temperature is recorded. So from there you can do the calculation. Okay. A. Draw the energy level diagrams for the reaction in the diagrams. Now explain the difference in the energy content of the reactants compared to the products. So 4 marks. So energy level diagram. So you have to mention energy in this axis. So the energy levels for the reactants must be higher than the products. Okay, then remember to put in the delta H. So the reactant silver ions with chloride ions, then the product is silver chloride. Huh? Okay, so 2 marks for the energy level diagrams. Okay, you have to explain the energy content for the reactants is higher, okay, or the product has a less energy content. So heat is released during the experiment, so this is exothermic reaction. Okay, for me it would be 2 marks from this point. Oh, but you also can mention about this because this is exothermic reaction. Oh, so formation of the silver chloride is a white precipitate. It's a solid. Okay, B. Table shows the heat release when for experiment 1, 2, 3 using different acids that has been reacted with sodium hydroxide solution. So this is a neutralization reaction. So experiment 1, 2, 3. This one is you can see the acid used are different. So set 1 is a hydrochloric acid, is strong acid. Set 2 is weak acid, ethanoic acid. Set 3 is sulfuric acid, is a strong acid, strong diprotic acid. Okay, so you can see the heat release, okay, is different. Set 1, set 2, and set 3. Okay, so release means you have to see, you must know that it has a negative sign here. Negative sign shows the heat is released. Okay, so back on the table, explain the difference with in the heat release between the 1 and 2 and 1 and 3, so 6 marks. So now I show you a video how we do the heat of experiment for the heat of neutralization. So I show you the hydrochloric acid. So
reaction. Watch the video and answer the following questions. 50 cubic centimeters of 2 mole per cubic decimeter sodium hydroxide solution is poured into a polystyrene cup. The initial temperature of the solution is measured with a thermometer. Record the reading in the table provided. 50 cubic centimeters of 2 mole per cubic decimeters hydrochloric acid is poured into a polystyrene cup. The initial temperature of the solution is measured with a thermometer. Record the reading. Calculate the average temperature of both solutions. Hydrochloric acid is poured into a polystyrene cup containing sodium hydroxide solution. The mixture is stirred and the final temperature of the mixture is measured with a thermometer. Record the reading in the table provided. What is the difference in temperature during the reaction? Key in your answer in the table. Now, with the data we have, we can calculate the heat released from the reaction.
okay, so this is how we do the experiment for the heat of neutralization. But here you just need to know how to explain the difference between the heat release for the experiment 1 and 2 and 1 and 3, so 6 marks. Okay, so experiment 1 and 2, so we compare. Okay, so 57.3. Normally you will see a negative sign in front of it. Okay, so you must know negative shows the heat is released. So 57 still higher than 655. So experiment 1 and 2. Okay, so heat of neutralization of experiment 1 is higher than experiment 2. Why? Because hydrochloric acid and hydrochloric acid is a strong acid and ethanoic acid is a weak acid. Okay, then strong acid ionized completely, then weak acid ionized partially in water. Okay, then some heat release, some heat release are absorbed by the weak acid. No, there is the weak, the ethanol acid, to ionize the ethanol acid in the molecules completely. So some heat during the neutralization is absorbed by the ethanol acid molecule to ionize completely. Okay, so that is why the heat of neutralization for the weak acid is lower. Okay, so 1 and 3, hydrochloric acid is the monoprotic acid and sulfuric acid is the diprotic acid. Or you can mention number of hydrogen ions in the sulfuric acid is twice. So experiment 1, 1 mole of hydrogen ions react with 1 mole of hydroxide ions, produce 1 mole of water. So heat release is 57 kilojoule. So for experiment 3, 2 moles of hydrogen ions react with 2 moles of hydroxide ions, produce 2 moles of water. So heat release is double, 2 times 57 kilojoule. So it's 114.6. Okay. Now describe the laboratory experiment to determine the heat of combustion of named alcohol with the number of carbon atoms per molecule less than 4. So you can choose methanol, ethanol, and propanol. In the description, you include the steps involved in the calculation. So total is 10 marks. 10 marks. So you are given the heat capacity is 4.2. Density of water is 1 gram per cubic decimeter. Okay. So let me show you the video how to conduct the experiment heat of combustion.
The burner containing ethanol is weighed on the digital electronic balance. Record its mass in the table provided. A copper can filled with 200 cubic centimeters of water is placed on the clay pipe triangle. A thermometer is then placed in the water. Record the initial temperature of the water and the mass of water in the table. The burner is placed below the copper can and then lighted to heat the water efficiently. The water is stirred until its temperature increased by about 50 degrees Celsius. Record the final temperature of the water in the table. What is the difference in temperature during the reaction? Key in your answer in the table. The burner is weighed again on the digital electronic balance. Record its mass in the table. How much ethanol has been burnt during the reaction? Key in your answer in the table. Now, with the data we have, we can calculate the heat released from the combustion.
Okay, so we can proceed to the procedure. The first one, you can put 100 to 250 cubic centimeter of the water is measured and pour into a copper can and place on the tripod stand. The initial temperature of the water is measured and recorded. Then a spirit lamp with the ethanol is weighed and its max is recorded. The lamp is then placed under the copper can and then the wick of the lamp is lighted up immediately. The water in the can is stirred continuously until the temperature of the water increased by around 30 degrees Celsius. Then the flame is put off and the highest temperature reached by the water is recorded. Then the lamp and its contents are weighed again immediately and the mass is recorded. Here you have to weigh it immediately because the alcohol actually it can easily evaporate. Okay, it vaporizes easily. Okay, so from the data you can use the unknown. No need to give any value of the answer. So here you can put the highest temperature is, let's say you put T2 degrees Celsius. You must remember to put the unit. Initial temperature is T1. Okay, T1 degrees Celsius. So the increase of the temperature will be T2 highest minus the T1. Okay, degrees Celsius. So after that you can use the unknown here for your calculation. Mass of the after the burning is m2 gram, and before is m1 gram. So the mass of the alcohol burn is m1 minus m2, okay, gram. Okay, so we can use the data here for your calculation. Okay, so for the calculation, so first one we can put in the number of mole for the ethanol. Okay, so the m2 minus m1 divided by the molar mass of the ethanol is 46. Okay, let's say it's A lah. We use the unknown A mole. Okay. Number 2, the heat energy release is M for the volume of the water is 100 times C is 4.2. The theta temperature change is T2 minus T1. Okay, let's say you put B joule. Okay, B joule, then divide by 1000, you get C kilojoule. Okay, then the heat of combustion is delta H is a C kilojoule divided by the number of mole is A. So let's say is D kilojoule per mole. So this is how we calculate the heat of combustion. So remember in the essay, especially when you're asked to do any calculation, so you can use the unknown like this, okay, to show your calculation. Okay, so thanks for watching.